My name is uh, Muideen Waliu, popularly known as what Dr. Nefon. So I'm a part one medicine and surgery student of University of Ibadan. So the first and the best university in Nigeria. So today I'll be taking us stoichiometry. So one of the best and important topic in chemistry that all jam bites have to know before they can go to any other topics. So now, please just take your pen, your book, and get ready for this class. Very very simple, and I'm going to speak every aspect of this topic very very well. So now let's continue. I said what we are going to stoichiometry. Now this stoichiometry was coined from two names. The word stoichiometry was coined from two Latin names, which is what? The stoichion and the metro. So these are the two names that coined the word stoichiometry. So stoichion means the particles, the smallest particles, or let me just say the words, the amount of a substance, why metron means what? Measurement. So anywhere you see metron in chemistry is what is means what? The measurement. So now if you want to combine it together now, stoichiometry is what? Is a branch of chemistry that deals with the what? With the measurement of the smallest particles, or the measurement of the amount of a substance, which means what? Mole. That's why in some textbook your stoichiometry is what? Is known as what? Mole concept. Have you get now? So stoichiometry means what? Mole concept is on what? Is on textbooks. Now, having know these aspects, the next thing to know about this particular topic is what? Is anywhere you see one mole of a substance is equal to one Avogadro constant. One mole of a substance is called what? One Avogadro constant. And one Avogadro constant is equal to what? Is equal to 6.023 times 10 power 23 per mole. That's the unit of Avogadro constant. So per mole. Now, and Avogadro constant can be represented as Na, or capital N. That means anywhere you see Na, they are talking about the word Avogadro's number or Avogadro constant. So which is called what? 6.023 times 10 power 23. That's the first thing you have to know. Also, one mole of a substance is equal to GMV. One mole of a substance is called to GMV. Now, what do you mean by GMV? It means gas molar volume. One mole of a substance is equivalent to what? To gas molar volume. Now, JAM sometimes use GMV, or they sometimes can use what? Gas, the volume of the gas at STP. Now, what I mean is that anywhere you see GMV is the same thing as what? GMV is called what? Volume of gas at STP. Gas molar volume is the same thing as what? Volume of the gas at STP. And anywhere you see STP, so it means standard temperature and what? And pressure. Anywhere you see what? STP, it means what? Standard temperature and pressure. So GMV means what? Gas molar volume, which is called what? Volume of the gas at STP. And note that my volume of the gas at STP, volume of the gas or gas molar volume is equal to 22.4 dm³ or 22,400 centimeter cubed. That means 1 mole of a substance, 1 mole of a substance is equivalent to what? To gas molar volume, or is equivalent to volume of a gas at STP, which is equal to 20.4 in dm³ and 22,400 centimeter cube was in centimeter cube, because 1,000 centimeter cube equal to 1 dm³, which is equal to what? 1 liter. Now note this very well. Now, having know all these things, so the next thing is to know is what? 1 mole of a substance is also equal to what? 1 Faraday constant. 1 mole of what? Of a substance is also equal to what? 1 Faraday constant. Are we there? So, and 1 Faraday constant is equal to 96,500 coulomb. Now, let me go back again. I said 1 mole of a substance is what? Is equal to volume at STP, or gas molar volume, which is equal to what? 22.4 dm³ or 22,400 centimeter cube. Also, 1 mole of a substance is equal to 1 Avogadro constant. And what's one Avogadro constant? 1 Avogadro constant is what? Is 6.023 times 10⁻23 per mole. And the last one is what? 1 mole of a substance is equal to 1 Faraday constant. And 1 Faraday constant is equal to what? 96,500 coulomb. Those are the basic things to know about stoichiometry. Now, having know these basic things, the next thing to know is what? Is formula for number of moles. Formulas for numbers of moles. The formulas for numbers of moles. Number 1, number of mole equal to mass over molar mass. That's the first one. Number of mole is what? Mass over molar mass. Second one, number of mole equal to concentration times volume. If it's in dm³, that is CV. Now note, if your volume is in dm³, the formula you are using is what? Is concentration multiplied by volume, CV. But if volume is what? Is in centimeter cube, the formula you are using here is what? Number of mole equal to concentration times volume over 1,000. Again, class, if volume is in dm³, which one are you going to use? Is what? Number of mole equal to concentration times volume if it's in dm³. But if it is centimeter cube, you are using what? Number of mole equal to concentration times volume divided by 1,000. And my C is what? It has a unit of what? Of mole per dm³ or molar. My V is what? This can be centimeter cube or dm³. So that's the formula. Now note, there are 2 types of concentration in chemistry. There are what? There are 2 types of concentration in what? In chemistry. Now, the first one is called mass concentration. There are 2 concentration in what? In chemistry. We have what? We have mass concentration and we have molar concentration. Now, your molar concentration is otherwise called molarity. And that one has a formula, it has a unit called what? Mole per dm³. Or what? Or molar. mole per dm cube or molar. That's molar concentration or molarity. But mass concentration is measured in what? In gram per dm cube. So mass concentration is what? Is gram per dm cube. While molar concentration or molarity is what? Is mole per dm cube or molar. That means if I said 1 molar, it means that it's the same thing as what? As 1 mole per dm cube. If I say 2 molar, it's the same thing as what? As 2 what? 2 mole per dm cube. Now, if you write it in mole per dm cube, your m will be small letter. If you write it in mole per dm cube, your m is what? Is small letter. But if you write it in molar, it will be capital what? Capital letter. 1 molar, which is called what? Which is the same thing as 1 mole per dm cube. 2 molar, which is the same thing as 2 mole per dm cube. I hope you are getting that. So now the next formula is what? Is now number of mole is equal to PV over RT. This equation, this formula is actually gotten from what? From ideal gas equation. From ideal gas equation. Now, this formula was obtained from what? From ideal gas equation. And ideal gas equation is what? Is PV equal to nRT. So if you make your N the subject of the formula, you will be having what? PV over RT. Where my N is what? Number of moles. My P is what? Is pressure. In what? In ATM. My V is what? Is volume. In what? In dm cube. My R is what? Is gas constant. Gas constant is my R, which has a unit of what? Of ATM dm cube per mole per Kelvin. Now again, ATM dm cube per mole per Kelvin. Gas constant is what? Is ATM dm cube per mole per Kelvin. And the value of gas constant is 0.0821 ATM dm cube per mole per Kelvin. So that's our gas constant. And my T is what? Is absolute temperature. Is what? Absolute temperature. Anywhere you say absolute temperature, it means temperature in Kelvin. Temperature in what? In Kelvin. So this is another formula. I said our N is what? Number of mole. Our P is what? Is pressure in what? In ATM. My V is what? Is volume in dm cube. My R is what? Is a gas constant. And its unit is what? Is ATM dm cube per mole per Kelvin. And the value is what? Is 0.0821 ATM dm cube per mole per Kelvin. And my capital is what? Is absolute temperature. That is temperature in Kelvin. It means that if they give you in Celsius, you have to convert to Kelvin. And by using this formula, T degree Celsius equal to T degree Kelvin equal to what? T degree Celsius plus 273. For example, now, if they give us 5 degrees Celsius and I want to convert this to Kelvin, I'm going to add 273 to it. So that's the meaning. So the next formula is what? Is number of moles. Number 4. Number of mole equal to volume of gas all over volume at STP. Now, number of mole equal to what? Volume of the gas over volume at STP. And what I call STP for you? Standard temperature and pressure. Definitely, number of mole equal to what? Volume of the gas divided by 22.4 in dm cube or 22,400 in what? In centimeter cube, depending on the volume they gave you what? The questions. So the next one is what? Is number 5. That's what the last one under the number of moles. Now the last one is what? Is number of moles equal to number of atoms or particles divided by Avogadro constant. And what did I call your Avogadro constant for you? I said my Avogadro constant is 0.023 times 10 to the power 23. That are the formulas for the number of moles. If you want to know anything about number of moles, you have to know all these formulas. But there is one formula that students don't understand, and this formula is obtained from the electrolysis. And the formula is what? Making number 6. The formula is what? Is very I don't know, maybe students know about that formula, but number 6 is what? From Q equal to NCF. Our Q here is what? Is the quantity of electricity. Q is what? Quantity of what? Quantity of electricity. My N is what? Number of moles. My C is what? Is the charge possessed by elements. And this F is what? Faraday constant. Now, if you make your N the subject of the formula, it means that what? My small n will become the what? Quantity of electricity divided by small c multiplied by F. This is what? Quantity of electricity, the charge of the element, and the Faraday constant. Note that my quantity of electricity is equal to what? Current multiplied by time. Anywhere I see my Q, so it means what? Quantity of what? Of electricity is equal to what? Current multiplied by time. And my current is what? Is in ampere. My time is what? Is in seconds. Are we there? That means anywhere I see what? I see my Q, I can say number of mole equal to IT over CF. That's another formula. So in the next class, in the next video, I'll be solving different questions on these formulas for the number of moles. So again, let me introduce myself. My name is what? Muideen Waliu, popularly known as what? Dr. Nefon. And I told that I'm a medical student, first year medical student of University of Ibadan. So this is where I'm going to stop the videos. So in the next class, I'm going to solve questions on the given formulas. So thank you. So subscribe on my YouTube channel for more difficult topics. Now I'll be sending and posting different videos on some difficult topics in chemistry. So thank you once again.